Okay, so today we're beginning a new chapter. We're going to focus in on those things that can be dissolved in water. We're going to ask ourselves, what is a solute? What is a solvent? What are the factors that affect how quickly something can dissolve? And finally, we're going to look at some solubility curves and how to get information from them. All right, so what is a solute? What is a solute? A solute is that which is dissolved. And a solvent is that which does the dissolving. By the way, do not forget that if you're struggling with ionic compounds, how to write them, how to name them, where can you go in order to learn? YouTube. I have a YouTube video called Thinking Through Chemistry, How to Write and Name Ionic Compounds. All right, so what is solubility? The maximum amount of solute that can be dissolved by a solvent. Who's ever been to Myrtle Beach? Myrtle Beach, you know that there's thousands of hotels in Myrtle Beach of different shapes and sizes. They all have one thing in common. They have this sign that says, no vacancy, to let you know if they have no vacancy. What is vacancy? Vacancy is rooms that are open. Okay? Every hotel has a capacity. This is how many rooms we have. This is how many people we can hold. Think of solubility as the capacity for any solvent. There are many, many different solvents. Every solvent has its capacity. Usually it's measured in the number of grams that 100 grams of a solvent can hold. The number of grams that 100 grams of solvent can hold. It is the number of grams that 100 grams of solvent can hold. Typically, if you're trying to decide between a solute and a solvent, the easiest thing you can do is just ask yourself, self, because I call myself self. Self, which one do I have a smaller amount of? So if I have salt water, what do you have a smaller amount of? Salt or water?
Salt.
So salt is your solute, water is your solvent. Air, what do you have larger amount of?
Nitrogen.
Nitrogen. So nitrogen is your solvent, and what would be a solute in air?
Oxygen.
Oxygen, or
Like the other category?
the other gases, which could be carbon dioxide or helium, some argon in there. What are the factors that affect solubility?
Is that it? Yeah.
Temperature is one. The hotter something is, the hotter the solvent is, the more it can dissolve. Good example of this is the difference between iced tea and hot tea. We'll talk about it here in a second. Pressure. Why is it that every time you open up a can of Coke, you hear the hiss of escaping gas?
Carbonation.
Because we like carbon dioxide inside our drink. It gives fizz to the drink. It literally, the stuff, the bubbles get on our tongue, and they take the heat away from our tongue in order to go back into gaseous form. We like that. It makes our tongue and our mouth feel refreshed. It cools down our throat. Even warm Coke, as long as it still has the fizz, can still be refreshing to you. Okay? But in order to have that much carbon dioxide, which is unnatural, in order to have that much carbon dioxide in water, you must put it under pressure. You must pump a lot of air in there in order to shove the carbon dioxide in there. And of course, the greater the amount of solvent, the more solute you can dissolve. If it looks like it's saturated, and that's a word that we're going to use, we're going to learn here in a few little while. If it looks like it's saturated, then just add more solvent, and hopefully it'll dissolve. So the factors that affect solubility are temperature, pressure, and the amount of solvent. So what happens when a solute hits the solubility limit? It will appear as if no more will dissolve. But in reality, using our metaphor, if I say that there's no vacancy in my hotel, and Jackson comes in and says, hey, I need a room, I'll take his money, give him, kick Kelsey out, and give him Kelsey's room. No, too bad, Kelsey. And that really does happen. If you think it's not dissolving, it actually is dissolving. But for every bit that dissolves, something that was dissolved must come back out, must recrystallize. It's called dynamic equilibrium. Dynamic equilibrium. So, if you were to stir it or give it enough time, will more dissolve? If you have reached its limit, the answer is no. You've reached its limit. So, why is temperature important? Because as we saw last week, literally water molecules have to come in and pick it apart. Well, what will the heat do to water molecules? Make them go faster. So if it's something that they would normally do slowly, you make them do faster. So heat is going to make you be able to dissolve more of the solute. I don't buy into this myth that Southerners are dumb. Okay, the Northerners think that Southerners are dumb. I completely disagree. I think Southerners make better chemists than Northerners. I'll give you two reasons. Number one, moonshine. Everyone knows Southern moonshine is better than Northern. Jack Daniels, everyone knows that Jack Daniels makes the best whiskey. Period. End of story. And the thing that you're probably most familiar with is sweet tea from McDonald's. Because Southerners know that what you do is you get the tea so hot that it is about to boil, then you break open a package of sugar, and when tea is that hot, you can pour that entire package of sugar and it will dissolve. And then all you have to do is add some ice. Bam! You've got enough tea to make your tongue explode. You've got enough sweetness in that tea to make your tongue explode. You know what I'm talking about. Okay? Northerners have... That's why when Northerners come over here, they'll look at you and go, well, you know, I don't want sweet tea. And then they'll proceed to put a pile of sugar down on the bottom of that iced tea that's about an inch thick, hoping to get it as sweet as Southerners get it, because they refuse to have sweet tea. Okay, because they're just not as smart as Southerners. All right, so which one can you dissolve more sugar in? Southerners know that if you make the tea super hot, you can dissolve a lot of sugar in it. Emmy, you were shaking your head. You disagree? You don't like sweet tea?
I don't. I'm from Nebraska.
There you go. You're a Yankee.
But we do have sweet tea.
Oh, please. It's north of the Mason-Dixon line. It's not the same. All right, so what is a solubility curve? It is a graph that's going to help you understand how these things all work out. It's going to have solvent, water, on one axis, the amount, and then the temperature on the other axis, and then it's going to be the amount of solute that can dissolve over a temperature range. This is one of those things I can describe it as best I can. It's best just to, and it won't make any sense, it's best to see it. Let me show you a solubility curve. There is a solubility curve. See it? Okay, so you have temperature down here, and then this is the grams of solute per 100 grams of water. So it's always per 100 grams of water. So what happens, oops, sorry, I still haven't changed my touch screen. So what happens to this graph as the temperature increases for all three of these things? Exactly. All right. Let's see if we can interpret this graph in order to get some information. Using the graph, what is the solubility of KNO3 at 0, at 50, and at 90? So what you do is you go to 0, and where does KNO3 meet? Right there. So what's the answer?
15.
Around 15. I usually put a little squiggle. That squiggle means around 15. 15 grams. Around 15 grams. Okay, the next temperature is what? 50? Okay, going up, going up, going up. Bam. Around, so 50, up, around.
85.
Obviously with this, I'm not going to be able to pinpoint it. I'm not going to expect you to put down 84 because it's really up to your interpretation. What about at 100? Oh, 90.
200.
I can. You just gotta look real hard. You see what I'm saying?
Oh.
Yeah.
200. So I will be expecting you to do this tomorrow's homework, but if you want to go ahead, well, I don't know if you have a graph. I'll have to have a graph for you. All right. So